So let's first of all have a look at what this terrain looks like when we, what these rocks look like when we render them with the terrain. So I'm going to go up to our landscape input, the cache here, and put down an object merge. And we can just reference this file input. There's no need to have a separate file input for this. So we're going to move down here to where this object merges. It's kind of like a portal. So you can see when we look at it, we can see that terrain in once more. We can go ahead and just hit merge, put down a merge, sorry, and we can look at the rocks now rendered on top of the terrain. And we can start to get a sense of how this is going to come all together. I am noticing a slight disturbance here, which is that the rocks do appear to be sitting above the terrain. So I'm not entirely sure why that's happening. And probably I'm going to need to reproject something back to the terrain at some stage. So we're going to go ahead and actually take this object merge and we're going to look at each step one by one to ensure that things are sitting correctly on the terrain. So this remesh is still nice and close, and nothing wrong going on at this stage yet. That's slightly worrying. I think the terrain rendering, what's going on? There's the terrain, that's fine. Merge, I think it's just a visual bug, but I'm not entirely clear on that. This is a new one for me. So let's actually have a look at the output of the mask by feature, so the cropped terrain. And yeah, I definitely think we're experiencing some kind of visual bug here. So I might just go ahead and reload the current desktop and jump back inside. And we can hopefully now see that visual bug is gone. I'm just going to go ahead and set my background up to dark gray, turn off display environment lights as background. So I press D on the keyboard to get to the display options there. Okay, good. So yes, we can see the terrain. I don't want to see the masking, so I'm going to go back and look at the actual input terrain once more. And then we're going to go through each of these steps one by one. So let's have a little look. This is still sitting tightly to the terrain with the fracturing. This fracturing is still sitting tightly on the terrain. Then the inflated geometry, is this sitting on the terrain? It looks to me like it is, because we can see it poking out of the back there. Maybe we have some stuff that seems to be floating a bit. No, it seems pretty tightly conformed to the terrain for the most part. So it must be happening later, potentially when we're doing our noise. So the sharpening, yeah, these guys, this looks like maybe the culprit. It's the point at which we sharpen the rocks. So the attrib noise here is the definite culprit. So we need to go and address this noise and make sure that it's operating at a scale that makes sense. So I'm going to go ahead and decrease the amplitude down to a couple of meters. Obviously we're going to lose some of that appearance there, but I think I just need to change the element size now to get some of that noise back in. We can go ahead and increase the strength. And I think actually potentially the issue is here that I'm going to have to make sure that it's operating in the sort of kind of local space of the mesh, or in the tangent space. So I'm going to set the noise to be along the vector, which is going to be along n. And this is going to mean I'm going to have to go and change a bunch of these parameters. But it means that things are going to hopefully move more in relation to where they were originally. Now this is the capacity to change the appearance of the rocks quite dramatically. So we're going to have to make sure that we're being careful still. So I'm going to set the amplitude to 3. We can see that it's only in the positive direction. So what does that mean? Well, it means that basically these rocks are only going to gain volume via this noise, which is not helping the case here. So I'm going to set it to be 0 centered. And this is now going to be operating in both the positive and the negative directions. So hopefully we're going to preserve those original shapes a bit better. And let's go ahead and decrease that still a bit again, less overall noise. And then let's go and have a look at that end result. Okay, so I think now we're back in the realm of the volumes are where they should be. So you have to be a little bit more careful introducing large scale noise if you don't want to move things around too dramatically. And then if we have a look at the sharpened result, hopefully that's still looking okay. Yep, I would say so. So now we can go back and run that whole process once more. So we're going to have a little look here once again at the end. And it's going to take a little minute just to go through all those operations. Especially this little VDB step at the end, which is the slowest part currently. There we go. All right, so that's quite kind of more acceptable to me now. I still think there's some stuff that's not sitting on the terrain as tightly as I would like, potentially because of the noise of the exploded view, also an artifact of the inflate sometimes. So I would go through and clean these up. But I think globally, I'm pretty happy now with the way this is shaping up, getting a nice mix of smaller and larger shapes. So probably I'm going to take this over to Unreal at this stage. But just before we do that, if we just look underneath the terrain, we can see there's all this geometry here, which is never actually going to be seen from the player's perspective. So we need to deal with this. And there's a nice, pretty simple trick we can do here. So we can say, I'm going to put down a wrangle, and the first input of the wrangle is going to be the output of the rocks themselves, and the second input is going to be that terrain. And we can essentially compare the current position height v at p.y to the, so actually say vector pos equals v at p.y, or actually let's say even float rock, float height or rock height, or float rock y, there you go. And then we'll have float terrain y equals volume sample. So this is going to be the terrain height. So we need to get the first input, so actually the second input, the layer height at the current position. So we're going to say current pos, or let's say sample pos for complete clarity. So we need to define what the sample pos is. Well, when you're sampling a height field, it's actually a 2D volume, so it only has the x and the z coordinate, or the x and y, depending on what programs you usually use. So we're going to say vector sample pos is the current position of the rock, except we're going to get rid of the height from that position. So oh, that's the wrong way around. So we're going to multiply it by 1, 0, 1. So essentially, we're just saying the sample position is the, if you projected the rock down to the height field, we're going to get the height. Okay, that's what this is doing. So I'm just going to zoom in a little bit to make this a little bit clearer for those of you who may be unfamiliar with writing code. So it's quite a simple little snippet. And then we just need to say, is rock y higher than terrain y? So we can actually just kind of get the difference. So we can say f at dist equals, we can just say, I think, rock y minus terrain y. Okay, so this is going to give us a positive or a negative number, depending on which is higher. All right, so we can go ahead and look at this wrangle. And Vex wrangles are multi-threaded, running over all the points, so they're very fast. And we can actually go and color this distance. That's going to help us to visualize what we've now extracted from that wrangle. So we can say ramp from attribute, dist, and you can see that everything below has now been colored black, or it's actually below 0, and everything above is set to 1. And there's a beautiful, wonderful node in Houdini called clip. Massive fan of this one. In 20.5, they updated it so that you can now just type in the attribute you want to clip by. I'm going to clip by distance. And we can see now that when the value is below 0, we're clipping all that geometry out. When it's above 0, we're keeping it. And if we go ahead and look at the terrain and the rocks together once more, you can see that visually, absolutely nothing has changed, but now we're dealing with about half of the geometry that we were previously. So very important step. Now we just also need to make sure that we're actually dealing with healthy geometry now, and the clip node does have the capacity to create some unhealthy bits of geometry along the clipping seams. So in order to ensure that this is nice and happy, we're going to put down a divide node here, which is going to convert everything to triangles and ensure that we don't have any sort of rogue points anywhere. And this is now looking pretty decent. So I'm just going to disconnect these two things over here. And we're going to go through the very last stages of the cleanup for Unreal in the next video before doing the import.